Hey, while Donghwa is getting the laptop set up, I want to tell you a quick story. It's like the story of unexplainable outcomes.
Oh, I got it. Yes.
So literally last night, I'm cooking my dinner, and I'm not very frequently in the kitchen, and I'm using this hot pepper that my wife had bought and just stuck in the refrigerator in my meal. And I clean this hot pepper, clean all the seeds out of it, and inadvertently touched my eye. So evidently some of you know what this experience is like. It might have been the most painful experience of my life. My eye was burning, I couldn't open it, and she's Googling online, pouring milk in the eye, and we're pouring every fluid you could pour in the eye. Call my ophthalmologist, he says, no, just go wash it underwater. So I wash it underwater. Long story short, I'm fine today. I wake up this morning, I've got this I don't know if any of you noticed, like a little blister here, and my wife goes out and Googles it, and it turns out if you have too much of a hot pepper, it'll result in this little blister here. So, it's kind of a long segue to machine learning, but that's the whole goal, is trying to find these things that aren't directly related, but ultimately, have an outcome. So my name's Howard Levenson. I'm with Databricks, and I'm the general manager of our federal business. And I've got about 15 minutes to introduce you to the company, and then my good friend Donghwa from NewWave is going to give you a demonstration of our platform. So I think it's kind of cool that we're partnering here to do it. So as you can see, my slides are great. Let me tell you a little bit about, come on, Donghwa, get that stuff together. Anyway, my first slide is really just a little bit about the company. The company was founded in 2013 by a bunch of PhDs that were working at UC Berkeley and trying to find a better way to analyze big data. And long story short, there was a Netflix challenge at that time. You could win $1 million if you came up with a better way of solving this Netflix challenge. And they competed on that, came in second place, but they ended up founding the company. So they developed this framework called Apache Spark. And Apache, well, it was called Spark originally. In 2015, they donated it to the Apache Foundation as open source software. And about the same time, they stood up the company to deliver Apache Spark as a cloud service. And, oh, there we are. So since that period of time, Databricks, we still generate, I would say 75% of the code in Apache Spark is written by a Databricks employee. We're still the principal curators of Apache Spark. But we've also developed several other really important open source initiatives. One called Delta, that I'll explain a little bit later, and another one called MLflow. And these are all in the open source domain, and you can download them. It's delta.io and mlflow.org, I believe, if you want to get the bits. We currently have about 2,000 people using the platform. The cool thing about Apache Spark, and I'll explain it to you on the next slide, but it's just a generic big data framework. And the really cool thing about all the companies that you see on the slide here are, if you have a lot of data and you're trying to find insights, pretty much Apache Spark is the answer. And it's the de facto solution for big data analytics today. So whether you're Capital One, every time you swipe your credit card, you ever get those notifications from Capital One that says, are you sure you're buying this thing at the store? Well, that's Databricks doing it. We found for Regeneron a new treatment for liver disease by decoding the human genome and finding variants in there. And I can go through a lot of different examples on this chart, but the point is a lot of different use cases for Apache Spark. If you have a lot of data and you're trying to find insights, Spark's the answer. Next slide. So in the federal government, it's not surprising that we have quite a few customers. I'm probably not going to go through all of these, but amongst our biggest customers are Center for Medicaid and Medicare Services, and we partner with NewWave, where Donghwa represents, to pursue better solutions for healthcare, better clinical analysis, big data engineering frameworks to try to ingest all of the data that they're receiving from the states. And a lot of these are running on Azure. Not all of them, but TVA, Housing and Urban Development, Department of Transportation, U.S. Army Corps of Engineers, SBA, World Bank, all running on Azure. And Databricks is, and I'll show you later, a native Azure service. They call it a first-party service, but we are their preferred solution for big data analytics. So how many of you are familiar with Spark? How many of you could define Spark for me? Couple. Great. Okay. So let me define it for you in terms that I think make it understandable. First of all, it is just a distributed processing framework. What does that mean? So basically, the idea of Spark is to let a developer develop on one machine and have it automatically run on many machines. And the idea is if it runs on many machines, it runs many times faster. So it's a data parallel architecture. In the old days, we used to call these SIMD parallel computers, and now today they're done on distributed computers in the cloud. And it really is the successor to Hadoop's MapReduce. And it's the successor to MapReduce for a whole bunch of reasons. One is it largely runs in memory, and so it can be 10 or 100 times faster than Hadoop. It's programmable in a lot of different languages, including really preferred languages like Python and SQL that are rampant in the marketplace today, and R as another one. It's highly interactive, so it's a really good data discovery tool. You can type a command, say, show me what my data looks like, and get a sense of what it looks like right out of the box. It also does a lot of different things, and on my next chart I'll talk a little bit more about some of the things that it does. But it's got a SQL component. It's got a component that allows you to ingest streaming data in real time. It's got a machine learning library that allows you to parallelize these machine learning algorithms across many different computers. There's a graph processing framework in there, and so you can do kind of linked list analysis with it. And all of these are very common. A single developer can develop a data pipeline that ingests streaming data, that does some type of transformation to it, puts it in a data warehouse, and then applies machine learning to try to understand what that data looks like. It's also got a powerful capability called the data frame. And the data frame is kind of like a canonical table. And so it allows you to ingest data in any schema, in any format, and allow you to merge and federate those data sets very quickly and very easily. And most importantly, Spark is storage agnostic. So you can plug into any type of storage that you might have, whether it's Azure Data Lake or Azure Blob Storage or Cosmos DB or SQL Data Warehouse. We don't care what the data storage source is, and we don't care what the schema is. You can read all of that data in and federate it and correlate that data on the fly. Next slide. So what can you do with Spark? Well, fundamentally, you can do streaming ingest. Most of the time, you've got to do some type of extract, transform, and load. You've got to take these data sets that are in different formats and different schema and normalize them. You generally want to enrich the data in some way, shape, or form. And then you might want to put it in a data warehouse. And in fact, Spark can be what we call a just-in-time data warehouse. The data can be sitting in Azure Data Lake or Blob Storage, and you can create a data warehouse on the fly that understands SQL, that you can plug your Power BI directly into, and many of our customers use our platform just as a data warehouse. And then finally, if the data's sitting in Azure Data Lake, you don't have to export it from the data warehouse. You don't have to transform it in any way. You can simply point your Spark cluster at the data in Azure Data Lake, and now you can start to apply machine learning, graph processing, and some of the other functions that are available in Spark. Next slide. So I'm going to build this slowly. So the problems that we ultimately try to solve is if you try to do this on premise, and many people have tried for many years, it's hard to do. you've got to set up a cluster, you've got to get top-of-rack switches, you've got to secure the environment, you've got to load operating systems and all those other things. And, you know, in the federal government, which I suspect most of us here are, this could take 6 months, 9 months, a year just to get the infrastructure set up. The next problem is, as you ingest your streaming data, just build it. You tend to move this data into the data lake, and you're ending up working with stale data. It takes some time to go down through this pipeline before you can start operating on the data. And so stale data is a big problem. And then at the top of the chart, you've got data engineers. Their job is really to take the data, transform it, enrich it, and put it in a format that data scientists can leverage. And then they hand it off to data scientists. But generally, there's a little bit of problem here. The data engineers are not putting it in exactly the format that the data scientists want it. They're not putting it there in time. And so a lot of these data scientists actually end up redoing a lot of that work. And another problem is they're building solutions that business analysts want to evaluate, but there's no connectivity across these three. So the Databricks attempts to solve this problem by building a managed service on Azure, something we call the Unified Analytics Platform. And the unification is really the unification of data engineering and data science in a single platform. We build this all on Apache Spark. That's kind of what our history is. But we've extended Spark. Like, we kind of figured out that, well, Spark's great at a lot of things, but it's not great at everything. In fact, if you want to do deep learning, there are libraries out there like TensorFlow and Keras and CNTK and many others that people prefer to use. And so we've integrated those frameworks directly into the Databricks environment. And today, if you want a cluster that has TensorFlow and Keras and XGBoost and scikit-learn and many other libraries, boom, 3 minutes later, we'll deliver to you a complete environment with all of those libraries integrated, all of the contingencies resolved, and a good solution. The other thing that we do kind of uniquely is we've introduced this open source project that I described called Delta Lake. And what Delta Lake does is, in Azure Data Lake, we provide the basic functionality to allow you to get something called ACID transactions in the data lake. So ACID transactions, just at a high level, are the ability, when databases have had this capability for decades, when you're building a transaction, let's say a debit from one account and a payment to another account, you only want that transaction to complete when the whole transaction is completed. We don't want the debit to complete and then the transaction fail and the money not be somewhere. So Databricks builds with Delta these ACID transactions that can build much, much higher reliability into the data lake. And so there's a whole bunch of other things that go on with Databricks Delta that I don't have time to go into today, but be assured that, you know, if you want high quality data in the data lake, Delta is one of the solutions there. At the top of the stack is really these collaborative notebook environments. So if any of you are familiar with Jupyter or Zeppelin or some of these environments for doing data science, they're very good, but they're not collaborative in nature. And so we build these collaborative notebooks that look like an O365 document that allow many people to simultaneously work together. So now your data scientist, your data engineer, and your subject matter expert are all logged in from different locations. They all see the same thing. There's interactive visualizations built into this environment, and you can, discover and build and create an analytic that everybody's part and parcel to. And of course, because we're kind of a data warehouse, you can plug in Power BI directly to this environment and use that as your dashboard. And Databricks wraps it with high security and obviously satisfies many of the federal requirements. Next slide. So I just wanted to talk briefly about Azure Databricks specifically. I mentioned that Azure Databricks, we're a first-party service there. But one of the things that we've done that I think kind of separates things is just the integration that we have with all of the Azure services. So you'll find that there's really tight integration with Blob and data lake storage. Databricks Delta was built on top of those platforms. There's really smooth ways of ingesting and exporting data from SQL Data Warehouse into Databricks. We connect with IoT Hub and Event Hub, so if you've got streaming data, this stuff is really easy to do, and it's been done many, many times before. Azure ML uses ML Flow, our machine learning lifecycle management capability, so that's integrated in. Azure Data Factory, I would say probably 60% of our customers use Azure Data Factory as an ETL engine on the way in. And of course, Donghwa is going to demonstrate to you ingesting data from Cosmos DB and other capabilities. So I think that's my last slide. So I would offer to you, we have a lot of expertise in Spark, in these deep learning frameworks and graph processing. If anybody's interested in actually testing this out and want our help in doing it, you could call us or you could call NewWave. We're happy to engage in a proof of concept with you. And with that, I'm going to turn it over to Donghwa, who's going to show you these capabilities in action. Thank you.
NewWave. We are a mid-sized company. We have about 400 employees. We grew about at 100% growth rate within the last 2 years. We have 11 prime contracts at CMS. We support 7 of their centers. And I'm proud to say that we are CMMI level 4 for both service and development. I know that there are only few companies that are out there who has achieved such achievement. Obviously, we serve Centers for Medicare and Medicaid Services, and we are into other federal agencies. As you can see on the logo, we are very much into healthcare, and that's what I'm going to talk about today. These are some of our technology partners, including Microsoft, Databricks, and Looker, Snowflake. And we are proud to say that because of NewWave and our initiative within CMS, we're bringing in both Databricks and Snowflake into Microsoft Azure Government. Those services were not deployed in MAG, but because of what we're doing, we are bringing them into MAG region. You can thank us. And as you can tell, some of the challenges that we have is around the security, right? Because healthcare and government, PHI and PII is very important for us to make sure that we're protecting the data of our beneficiaries. So FedRAMP is really important, and then we are helping some of our partners to achieve that. NewWave is managing chronic conditional warehouse, which is about 5 petabytes of data. It's one of the largest healthcare data repository out there. And we have helped Microsoft to be certified in some of their FedRAMP services. So we have very great security folks working for us. So that's about a NewWave. I'm going to get into demo. Let me see if this works. Nice. Okay. So Howard talked about Delta, and that's what I want to talk mostly about for my demo. And sorry. Okay, great. So just a little background. I'm a little bit ashamed to say this, but this was put together last night. I thought I was going to have the weekend, but then it turns out that I was called to go to Connectathon in Atlanta, Georgia. And I had to actually code within that hackathon session. But I think I pretty much captured what I wanted to do, and it kind of has the theme of Connectathon, which is hackers coming together, making sure that healthcare information is being able to exchange, right? Interoperability is the big theme. And we were attending HR7 FHIR. I don't know whether you're familiar with these terms, but FHIR is becoming the standard of exchanging information. So I sort of took on that theme when I created the demo. So that's kind of flow that I put together. So as I'm going to be generating synthetic patient data because I don't want to be using real data using a tool called Cynthia, which is a very popular tool. And using Node.js that's running on my local machine, I'm going to be sending it to Azure API for Fire. This is a managed service that's in the cloud. And in the backend, I have Cosmos DB as the backend for a REST API. And what Cosmos DB does is that it gives me a change feed. So whenever there's new information coming in, I can subscribe to it, and then I can either run Azure Function, or in this case, I'm utilizing Apache Spark Cosmos DB connector, which has change feed capability. And then I'm going to pipe that into Azure Databricks Delta Lake. And one of the things that Delta Lake is great for is creating stream, right? You can have a data set that you can call raw data or bronze state, and then you can do some transformation, and then you move that into silver state, which is queryable. And then finally, you can do more transformation, and then that becomes the gold standard on which you can do your analytics on. And you can do this without leveraging tool that's cumbersome to maintain and other things, just by creating different streams, read streams and write streams, so that whenever data is available within one of these data sets, then it automatically kicks off transformation, and I'll show you how that's done. So I'm not going to go over this. As Howard mentioned, it's ASIC compliant, and then it has very cool features like time travel. So if you are in AI, let's say you have created your model like 3 months back, and you want to go back to that same data set, you can do that using Delta Lake time travel capability. And it simplifies the Lambda architecture significantly. So if you wanted to, in traditional environment, when you are managing your data lake, then you had service layer and then streaming layer, which is for fast data. But with Delta Lake, that gets simplified, because Databricks supports that. And this is just my note to move into another notebook. So here, just going to a little demo. So this is how I set up Cosmos DB. I know you're going to be, let me try to analyze that a little bit. Can you see better? So basically, you provide the endpoint for Cosmos DB, and then key, which I'm not going to show you. Database and collection. Collection is like a table. And then change feed. And you can give a custom query that you can use to pull change feed. So right now you see this spinny guy here. It means I already have read stream that I'm subscribing to. And there is nothing showing here, but once I initiate some data flow by sending my synthetic data over to Azure Fire server, then you should see some action coming up, hopefully. Yes. Let's see if demo god is on my side today. Can do it? Oh, yes. So as you can see, the count goes up. It's streaming. Strip data is coming from Cosmos DB as change feed into Delta Lake. So I'm going to stop this. And I'm going to switch over to my main notebook. So as I said, the use case that I'm going to show you here is just dumping data from Cosmos DB as raw data set, no transformation, and then having read and write streams, so that the transformation from the raw state or bronze data set is applied automatically into the silver data set, which is queryable data. So I have already run this. So, the type of data that I see is like this here, right? It's pretty raw data set in JSON format, JSON string, nothing much to that. So what I'm going to try to do is I'm going to parse the JSON using JSON path capability that Databricks has as functions, so that I can parse out different part of the data. So this is a condition resource within Fire, meaning that conditions that patients may have, And it's pretty simple. I just do select on, like Howard mentioned, data frame. If you're familiar with Pandas data frame, it's the same concept. You can do transformation on data, row and columns, right? And then I'm just using simple JSON transformation. And this is sort of what we expect within the server table. So here, what I'm doing is I'm creating a stream between bronze table and silver table. Same transformation is being applied, but this time, what I'm doing is I'm creating read stream. Sorry, if you cannot see that. Is that better? Okay, you can tell me or throw things at me, and I'll make sure that things are. So I have read stream, and then I also have the write stream created. So this time, what I'm doing is I'm reading from my raw table, and then as I'm reading it, I'm doing this transformation, which is applied automatically as the data is available within the raw data set. And that transformed data set will end up within a server table, which is the one in the middle, right? So again, this guy is spinning, meaning that the read stream is created. So, and as Howard mentioned, the great thing about Apache Spark is that you can use whatever language that you're comfortable with. Scala, Java, Python, R, and obviously SQL in this case. So I run that. Come on, cluster. So just to go back here, I'm parsing this. Into what you see here, right? And this is done automatically. I don't have to, manage, any type of transformation scripts. It's all done via here. Whenever data is available, then it gets transformed. And I'll just do a quick one more demo. So there are 402 rows in the server table. What I'm going to do is I'm going to add more data to the bronze table, and I'm just going to show you that as data is added to bronze table, it automatically does the transformation and then moves the data into the server table. So I come here, and then I use this notebook to write data into the bronze table. That's done. Once that is complete, I should be seeing the change in the number. Sorry. So I run this number. Yeah, right now the number is bumped up. So that's pretty much it.